All right, good afternoon, folks. Thanks for stopping in today. I really appreciate it. Today, we're doing a bit of a different lesson than normal. There is one outcome in the basically scope of outcomes that I have to cover that I've actually totally forgotten about. And I read it and I was like, oh, I haven't even talked to these guys about it. And what it is the difference between a stringer bead, so just taking your welding rod, putting that nice line of weld on your steel or material, versus a stringer bead. Just make sure we can get the mic here. We got some extra noise in the background now. So a stringer bead is, the simple pass. Grade 10, you may remember doing lines on a plate, trying to build up all that padding and material. What we have also available to us is a weave. Now a weave is simply where we take that rod and we just do a slight little wobble side to side with our puddle as we travel down the plate. And then what that does is that takes your stringer width and makes it wider. So it's going to be good for capping materials and stuff like that. If we have a bevel in the plate and we want to fill that in, we can actually just weave and drag that material in there. It does have its limitations. It is good for certain things, but it isn't the best for other things too. So we're going to talk about those two different styles of welding, stringers versus weaves, and why we want to use them. When I think of weaves, first thing I start thinking of is vertical welds, weaving side to side, to side to side to side. That is very similar in the flat position. We call that a cap. And when I did the flux core weld, I had that slight side-to-side manipulation, and I did the cap all in one shot. And I'm going to grab that just so you guys can take a peek at it, because it's been a few days since we did that. All right, so what we have here is that flux core 1G. So this was the flat groove that we worked on. With this, we put the root in right down there. We put that root in with S6 solid wire. So gas metal arc welding solid wire for that root. Then we did the fill and the cap all full of flux core. And it was a backhand drag. So I had my nozzle pointed in here. I was pulling this way. I was just giving a slight little side-to-side wobble with my wire, taking my puddle left and right. And doing that gave me this one-pass cap. I was able to get the puddle wide enough to fill that groove, just put a little bit of reinforcement on it, which is what we want, just slightly above surface. And that was done in one pass. So that's cool. I mean, that's pretty much a standard for welding pipe. If you're doing pipe in the flat position, you want to weave the caps, but it does have its benefits and its negatives. And one of the big negatives with this is when you're controlling such a big puddle and you got so much heat, because you're taking that liquid puddle and you're warming this whole thing with it. So when you do a cap, these get quite warm. The problem with that is you've put a lot of metal in one pass. When that cools down, that steel shrinks, and that's when that slag cap pops off, right? We've seen that kind of, where that slag will crack on the sides. We can kind of flick it off. That's because the steel has shrunk somewhat. Because obviously hot things expand, cool things contract. And what happens here, though, is as this contracts, it actually imparts stress on this plate, and starts, as this weld shrinks here, and pulls the edges of the plate up just a little bit. Now, it's hard to see on such a small distance, but if we were to have these longer, we would actually be able to see the slight bit of stress in there. And the more and more you weld on this, the hotter you get it, the more stress you're going to find in a plate. So some of the plates we welded on and did things like our stringer padding on, I'm going to grab one. I'm going to show you, and it shows a really good example of that stress in kind of real life. So what I've got here is a gas metal arc welding padded plate. This is something I whipped up for students just a little while ago. Put a whole bunch of stringers on there showing them gas metal arc welding. And it looks pretty decent. There's no weld on the backside. And this is going to help outline what we're looking at today. So what we're looking at today is that bit of a curve. So this was a completely flat 3-inch by 3-inch plate when I gave it out. Now each one of these passes has imparted just a little bit of stress on this plate, and we can see that it's got a bit of curve to it. If we were to do big wide weaves, and say I put 5 weaves on here, you could see this exaggerated probably quite a bit more. There have been some studies done at SAIT. There's a gentleman by the name of Jason Purdy. He runs the welding department at SAIT. And at SAIT, they've got a lot more facilities than we have, including a weld engineering technologist lab. So that's where they analyze welds and processes and figure out what is the best process for welding certain types of materials. And what he's done is he has measured and calculated and used infrared cameras and looked at stress and heat inputs. And basically he's determined that when we do a weave weld, or if we stack multiple weave welds, so 1, 2, 3 weave welds on top of each other, the stress that it imparts on the material is very likely to bend it in. If it is restrained and you weld the ends of that plate down so it doesn't move, and then you weld that middle, what's going to happen is it's going to create a bunch of preloaded stress in that material. Chances are it's going to want to break the tacks on the ends there. And if it doesn't do that, what it could easily do if it's not de-stressed properly, and you can do de-stressing by heating a piece up quite hot and slowly cooling it down, letting it all normalize evenly. Because on a bigger plate, we got a couple 6-inch plates, let's say, and you weld right in the middle. We got a whole lot of heat right in that middle of that joint. Say if these were beveled plates, we got a lot of heat right in there, and it would suck those ends up. That's not what we want. So there are ways of controlling it, but minimizing heat input, especially if it's on something, say a customer project that is fairly sensitive dimensionally, like it's got to fit in this space and it's got other parts it works with. Running multiple stringers instead of a big weave cap is going to be a good way to reduce stress overall, because you have a smaller heat input and the heat dissipates a little quicker from it. You're not shocking this material with just a whole buttload of heat right off the bat. You're introducing heat gradually, stringer by stringer, warming the whole thing up in kind of a slower process, and then it'll cool in the slower process. Whereas if you are using weaves, you're just laying that great big fat weave in there, and you figure, just 1 pass is all good, or 3 passes is good. You're just introducing so much heat into that area, it creates a bunch of stress. And then what happens is, if you got cooler steel on the outside, it detracts, it removes heat from the inside there, and actually can cool that weld off a little quicker than we want too. So there are advantages and disadvantages to either system. I'm going to go over examples of both today. So we're going to, I wish this camera would just stay focused. If I just don't move at all. There we go. All right, that's not too bad. So I'm going to take 7018. I've got a couple plates, and we're going to do stringer passes, and I'll walk you through every step of that, and then we will do weave passes, and then we'll do those steps. So it's going to be 2 options. Weaves, when using them as a cap, can be used in the flat position, and obviously vertical if you're going uphand. You can use stringers in the uphand. Horizontal, you're going to want to be using stringers. Easier to control a smaller puddle. If you're trying to weave, firstly, weaving up and down, we got this thing called gravity, right? That's going to take all of that liquid steel and pull it down, and you're going to end up with a great big mess with the weld with a big belly on it, steel on the floor. You know, could just be a big mess. It isn't going to be pretty. So I've got a little piece behind me right here, slightly warm. I have tacked it up, and I've got bevel there with nothing inside of it, and we're going to fill that one full of stringers. And then I've got one here on the back side. We're going to fill full of weaves, and we're going to compare the two. So for this, I've got my welder set at 116 amps. I'm going to bump that up to 120. It's kind of where I like to operate. Recommended settings for a 1/8, especially a 7018, is going to be about 120. So that's a good thing to keep in mind. I need to locate my safety glasses because I seem to have misplaced them. And then, oh, they're on my side. Then we will get rolling here. So I'm going to try and keep the clanging and banging down to a minimum. I'm going to try and keep it off the table when I do it, just because it's noisy, and you guys don't need to hear that. But what I am going to do is we're going to just, the first pass in this is just going to be a fill pass. It's just to make sure that I've got a good base to do my demo welds on. The first pass is not important with this. If it was, I would be doing groove welds. I'd be putting the root in there. And I would have proper spacing on my plates. But right now, I've just kind of jammed these plates together just so I don't have any burn through when I fire this up. So we're going to put the first pass right in there, and I'm just going to lay it in the flat and just run that pass right through and join these plates up. Then we'll start the real stuff from there. So yeah, welder's set up 116. We're going to go to 120. I've got arc force set at 40%. I don't want too hard of a dig, so 40 is great. Ground clamp is hooked up, which is awesome. That'd be pretty embarrassing to start this welding and not have my ground clamp hooked up. Big old amateur fail right off the start. All right, so we're gonna have some rods. Got a couple right here. And we're gonna go for it. So please excuse this camera. It's probably gonna be all blinky and gross, but yeah, we'll get there. All right, here we go. So I'm just laying this one in here just to make sure that I got a nice solid base on the bottom. I don't know if you guys can hear that, but it sound changed quite a bit. Yeah, that's because it burnt through. So now I'm trying to close a hole while welding and talking to you guys in the middle of a lesson. All right, so I got that hole closed. So what I'm going to do is work a little quicker so I don't burn through again. All right, so that first one's in. I don't know if you're able to hear it. Sometimes the mic picks it up, sometimes it doesn't. But I burnt through this plate, even though I was intending not to. Totally burnt right through it. So I was kind of fighting that the whole time, closing it up. But such is life. So we're gonna go cool this one down. It's gonna help me get rid of that slag. And then we're going to lay some stringers in there and show you guys that process. Now, just to let you guys know, if you're ever doing a weld test or a procedure, something like a CWB structural stick position, you never cool your steel, ever. What that does is it takes that hot material, cools it, it shrinks real quick. It also forms, it's called martensite and perlite inside your weld. And those are very, very brittle elements because the metal goes through a transformation. Basically, you heat it up, atoms, molecules moving around, and when you cold shock it, everything kind of freezes in place, forms these little hard spheroids of martensite and perlite because you've cooled it down quick. So it's a different process than if it would have cooled normally. And it's going to break your welds when they go to bend them. So it's makes your weld really hard and brittle. So even though the steel seems hard in the steel world, this steel, this regular A44, I think it is soft as can be. So that's why it bends nicely on like bend tests when you're doing CWB structural testing. Cooling it down like that takes all that ductility away, and it just snap, and then you're out like $200 for the test. Well, that's probably loud for you guys. Probably really loud. There it is. So we are doing this the easy way. I'm going to grab a grinder. I'm going to buff this up off camera. Then I'll bring it right back to you guys, and we should, hopefully, should save all that clanging and banging, because that was annoying. All right, so we have there is a weld with a sealed bottom, bunch of slag in it though. Doesn't really matter because we are going to weld over it. Normally I would never weld over slag, but for today's lesson, it's not a big deal. I was talking about burning through. Yeah, there was some burn through for sure. This is laying on top of the table. That's the only thing that kept that weld from falling right out. But yeah, we're gonna put a couple passes in here. We're gonna put some stringer passes in. So when I do that, what I'm gonna do is, firstly, knock this big chunk of slag off. I'm gonna take my rod, and we're gonna start with this bottom section here. We're gonna start on one side, and we're gonna put a pass right down, right on the one side, the one toe of the weld. That's where the bevel plate meets the edge of the weld there. We're gonna clean that up. Then we're gonna put a second one right down here, and that should fill the bottom in. Then we're gonna leave us a 3-pass cap on the top, and we'll do that all at one shot. So normally I try and use my rods up entirely. I'm gonna use these for tacking up other things later, but for today's purpose of today's demo, I'm gonna use full rods. So I'm gonna put a pass in here on the toe. I'm only gonna come out to the middle point of the weld, and then I'm gonna put a second one in on the other side And this is stringer passes here.
You want to make sure that you're not filling up that entire bottom with one pass, and that you're coming up the bevel a good ways so that with your top pass, you can fill that little gap and you're not forced to carry a whole bunch of material. So just kind of filling this in here. I'm using this pass to kind of fill all the mistakes and the inconsistencies from the previous one. Just getting that all taken care of. And at the end, I pause at the end for just a little second.
Well, that does that backfills the crater, and that's just a good habit to get into. When we do these welds, sometimes we end up with a crater on the end if we pull the rod out of there too fast. That's because the arc force has kind of opened up an area, and normally it should deposit steel in there, but since you pull that rod out so fast, there's a crater there with no weld in it. So that's a thing a lot of people do that isn't that great. So we're gonna see if we just can't clean this up with the wire brush. Maybe save us some chipping. So one thing we need to be aware of, and I'm going to take a picture of this, is I've cleaned all of this pass, except right down here, there's a bit of slag stuck in there because I have some slag nodules or spheroids stuck to the wall of this bevel, and that's holding that slag there. So I'm going to take a picture so you guys can see it better. Then I'm going to grab a grinder and we're going to remove that bit there because you don't want any slag in your welds when you're doing this. That's how you get a nice sound weld, is clean it out entirely every single pass. So we're just going to grind that out. All right, when we do that, we don't have to go crazy. I've just opened it up just a little bit to get that slag out. Now we're going to fill that in with weld pass. Actually going to use up these rod stubs for this pass too. So I can do that.
So we're just going to get in here and fire this one up. Ooh, there we go. I can see now. So somebody didn't turn the grind mode off on his helmet and just blinded himself a little bit. All good. So we're just laying this one in that little valley. This one always goes in really nice because you've got this support on both sides of the weld joint.
That's the end of that rod there. We'll load in this one. What we got to do is just chip off a little bit of slag on the end of that one. Now, I just spoke to you guys about filling in your craters. If you are tying in another rod, like I am right now, a crater isn't a bad thing. It gives you a place to start that weld. So you have to kind of be aware of where you are, how you set up your weld. Knowing your plan from start to finish is kind of a good thing. So I've just exposed that little bit of the end of the weld. We're going to take our next rod and we're going to tie right into that. All right. So that pass is done. So we're going to move on to the cap. Just a second here. We're going to buff this off and then I'll show you guys that. I'll show you the weave one. The weave one's faster. So here, hard to see, but there is the tie-in right there. That's where I started the new rod. That's where the old rod left off. New rod, finish that up. We are getting more full. As you can see, we're just 1/8 of an inch, even less below the surface of the plate there. So we are going to fill that in using 3, maybe 4 passes side by side with the 7/18 1/8 rod. All right, so for this, I am going to start up a new rod. With your caps, if you can save, you only have a limited number of new rods. If you could save new rods for the cap, it just gives it a much nicer appearance. We can often have little defects when we tie in rod to rod. And when you're doing a cap pass, it is kind of the show pass. It's one everyone sees. So it's always nice to have that full length pass on each one. So we're going to start that here. I'm going to fill this in. I'm actually going to turn this down a couple amps. It's a little warmer than I like. I'm going to turn it to 114. I'm going to go in there against that edge. I'm going to build it up so we're above the surface. And then the next 3 passes should just follow in real nice after that. So let's get this done.
And this is all stringer passes, so just dragging the rod in a nice straight line. No side-to-side movement with this at all.
So this pass should be right up to flush, if not a little bit above. So we'll just buff that off. All right, it's not bad. So what I'm going to do is I'm going to put some additional passes on beside it, and I will show you guys the end result. also, I had a bit of a fail last class. I forgot to open up your homework assignment for that day. So I opened that up last night. If you guys have a look at that at some point too, that'd be awesome. So what I do is I'm going to drag this in here and finish up this last bit. You may have seen I just kind of was looking at this like this for a second. What I do here is if I've got a rod stub that's longer than my weld, what I usually do is I just weld with that rod stub, and I usually have enough to finish my weld. If I got 6 inches of weld and 7.5 inches of rod, usually you can complete it. I may not. I may have to put, this rod section in here, but I'm going to try it anyways. This isn't something for a customer. It's not really being judged too hard, unless you guys are really in a judging mood today on this Monday. But yeah, what I do is I often just finish this up. And that's an easy way of checking just to see if you have enough rod for how much weld you have left to complete. So let's get this going and see how it turns out. You see that method works pretty well. I have 1/2 inch of rod left, and I was able to complete the weld on that plate. This weld is not as nice as I would like it to be. That first pass, I left myself quite a bit to fill. I didn't get a very nice first pass on there. We'll kind of talk about that in a second here. I'm just going to buff this up and show you guys this last pass. Just going to cool this down so it's easier to hold and discuss. Yeah, definitely not the best I've done. So what we have here is a completed weld. This side here, closest to me, this because I would have been working on it across my body. It's great. It looks good. It's got a nice, real clean line here on the finish. What I don't have is a good top line. I really tried to force that up the wall. I left myself a bit bigger gap than I wanted. And as a result, I'm low and I have undercut the whole way across the top of that weld. So not a great weld, but a great learning experience. So we need to fill those top edges up a little bit more as we do this. If we are, wondering, am I able to fill this up in one pass? Well, that's something that you guys need to figure out as you continue to work. You can increase your travel speed, decrease your travel speed to increase deposition on the plate. I should have put my first pass in a little better because I burnt through right off the bat, and that kind of set off everything on a bad foot to start with. And I was trying to play kind of catch up and corrections the whole way through. Not an ideal situation, but it does happen. Overall, in comparison to what I started with, turned out decent, but not something I would ever try and submit on a weld test. So what I'm going to do now is I'm going to flip this over, and I'm going to turn my welder way down, put in a good first pass on the weave side, and then we'll discuss the weave as I put that in. So So with the weave, we're going to be still working across our body, but if you were to look at it on end, you'd just see my rod, slight side-to-side manipulation, and that's going to direct the puddle. You don't want to go extreme because that puddle is going to be following the end of your rod. It's got a little bit of lag time, but it does follow it. So kind of moving in a bit of a pause isn't a bad thing. We don't want to travel across our plate with great, big, really fast side-to-side movements. You know, slow travel with even quicker movements sometimes isn't a bad thing. So it all really depends on how you want to do it. If you want to be slow, you'll figure this out as you get comfortable with welding. I can kind of adjust any way I want, but that's just me being familiar with this. So let's lay down the first pass. Let's lay down a weave and a weave cap, and we'll see if I can't maybe distort this plate a little bit. Take my 7018, I'm going to turn this down, turn it down to 110, which is below recommended. They recommend around the vicinity of 125, but you know, some people weld quite cold, and that's fine. As long as you're not getting inclusions, doesn't really matter. So let's lay this first pass in here. Hopefully better than the last one. All right, so that one went a little better. That's great. I didn't burn through the plate on that one. Quite happy with how that one turned out. I'm gonna cool this down so the slide comes out easier, and then we will lay in a nice hot weave on top of it. I kind of want to see if I can bend that plate a bit for you guys. Show you what I'm getting at. All right, so there's that first pass laid in there. Already we're looking better than the last one. I got a little bit of slag I got to pull out in that corner, but we're gonna lay a nice weave pass on top of there. Get this thing almost full. It's gonna be a big hot pass. Might have to use 2, maybe even 3 rods for it, but that's the nature of a weave. We burn a lot of rod in a short distance. swap out to a full rod. So we're gonna need it for this one. Okay, I'm gonna go back up to 120. And what I'm gonna do, we're gonna lay this in, a little side to side action, start filling this up. Nice slow travel speed towards my left side. So one rod down, we're almost to the end. So I'm gonna use up one of my stubs. Just gonna chip this end clean a little bit so we don't have any slag inclusion. Sorry for the noise, guys. Now that I've got that end clean, I'll pop right back in there with the rod and finish up that weld.
I don't cool it down between rods because that heat in the plate is going to help you. It's going to allow things to
settle out a little better, and that heat's going to allow you to burn out any slag inclusions that you may potentially have. So I always keep my plates hot while I'm doing passes. I'll cool them down between passes if they're not important, like this one. I can cool it down between passes, but I'm not going to. I'm just going to leave this one smoking hot. Hopefully put a nice big fat cap in there and show you guys some warpage. We'll see. So if you guys can see it, when we're doing that side-to-side motion with the cap, all the slag pops out really nice. We've got a nice smooth surface in there, and we go from edge to edge or bevel to bevel, so there's nowhere for that slag to get trapped unless you've made some issues manipulating the rod. So what I'm going to do is I'm going to fill this one up almost right full with the next pass, and then we're going to put one nice clean pass over the top. So the next one will be pretty much right to the top, and that's going to prepare us for our final cap pass. So this last pass here, I'm going to vary the thickness of it to make sure that my surface weld, my cap, is as consistent as possible. So you can kind of correct little mistakes as you go through. There are a couple little inconsistencies. I'm higher in the back spot here and lower across this end, so I'm going to even that out. Or at least I hope so. So I know it's going to take at least 2 rods for this one. So a couple rods here, and I'm going to go for it. Already I can kind of see stress in this plate starting. So I was talking about that deflection. We'll outline that afterwards, and I'll show you guys how that looks. So I try and pull straight down the length of the weld. So I actually hook my rod, my cable over the back of the table. So it's not pulling me towards my body. If it was hanging here, it's going to want to pull me towards myself. So I hook this over at the end of the table, and as your arm gets tired, that gravity falls, cable should roll right off the table and should help you keep nice and straight for those welds. So let's lay this last one in here and then we'll put the cap on it. Just a slight side to side right now. A nice big puddle. Slow travel speed. Filling this up. Oh, I was able to get through it in one rod. Look at that. So that was kind of in preparation for the final pass. Also kind of a repair pass. I wanted to even out the surface of this weld before I put the cap on it. Should look pretty good. I noticed one little spot. I didn't quite get the edge as much as I wanted, but shouldn't be too bad. What I love about these welds is if that cap is smooth, should pop right off because there shouldn't be anything that it's going to hold on to. And this one buffed off real nice and easy. And I've got the groundwork laid for what should be a nice cap pass now. So learning how to correct things on the fly is kind of what I like to do. So that there looks pretty smooth. It's almost flush the whole way. No major lumps, no major bumps, no holes, no big chunks of spatter in there, not like the first one. So when I was bugging you guys in class about setup is key, right? That ugly gross right there made all the difference on that weld. And this one, if you look at the backside here, I just didn't burn through, and it set me up really nicely for this weld. So that proper fit up and start up is definitely key. That's, I don't think I could show you a better example. All right, money pass. This for all the marbles. This is what we want to look good. So making sure you can move properly, you're comfortable, all of that. It all comes down to this. Every pass is important. The route's probably the most important, but it sure feels nice to lay down just the beauty of a cap. So not saying that I'm going to, I won't, just because I'm talking about it. I'm gonna have some inconsistencies in mind, and it'll be just a terrible example, but I'm gonna try for you guys. That's all we can do. So here we are, gonna start it up. And we're off to the races. So I take my puddle back and forth. The edges, make sure it fills everything up. No undercut. Hopefully anyways. So one thing you may notice, well, as you weld this, maybe not with this weld itself, but
as you stack pass, on pass, the puddle will get much more fluid. And that's just due to the heat in the plate. So learning to control more fluid puddle is a skill you guys will get as time goes on.
If you are struggling with that, one thing we can do is we can cool it down between passes. And that will take all the heat out of it every pass and give you a more consistent weld after weld. But it's not really the reality in the workforce because a lot of it is speed related. So giving everything time to cool down, especially since you can't cool it down with water, it has to kind of air cool, naturally cool down. We just won't have time to let things like that happen. So we're going to need to learn how to work with progressively more fluid puddles. So I don't know if you guys can see this one. A lot of the slag cap came right off. I have 4 inches of solid slag here. Kind of burning my glove a bit, so we'll set that down. Oh my gosh, that's ugly. All right, so for the most part, we've got a decent looking cap there. You can see it on the bottom. Right there though, hard to see, and I just burnt my glove again. There is some undercut there. I didn't hold one side as long as the other, and it did not fill in the way I wanted it to. With this, profile-wise, we don't want it to be any more than 1/8 of an inch taller than our plate. So I can set this one up this right way. You'll see that we have just a bit of reinforcement and not much more than that. And there's a ton of heat coming off this. I can actually see heat waves in the camera. But it gave us a fairly nice result. The welds like this are super useful if you're joining big sections of plate. I had a job once working in a sawmill, and they've got these concrete log ponds where they fill full of water, they put cut logs into, logs float down there, there's chains that pull the logs forward. The logs are beating up the concrete over time. So what we did is we lined all of these log ponds with steel plates. And I got paid literally all day long to sit on my butt and drag weaves just like this between the plates. I think it was like 16 feet long or 16 feet wide these ponds were. So we're just, pull 16 feet of weld, put in 2 more plates, weld the 4-foot seam between the plates, 2 more 6 or 8-foot welds going across, and it was all done with weave passes like that. Bigger rod to move faster, but weave passes. So this is something that you guys will, if you're in the welding world, you may end up doing a bunch of. It's not a bad thing, but a little hard to see here, but what we're trying to do is trying to create that stress for you. So what I'm going to do is I'm going to cool this down and see if we can find some stress. All right, so looking at this plate, both exhibit signs of stress. This one actually, the one with the weaves, shows more. The reason for that is that burned through at the back. So that was just a whole big fail on this lesson. But long story short, that's a weave. That's what I'd like you guys to practice when you get back in here. We're going to be doing it with stick. You can do stringer caps as well, but we've done some stringer caps. You will need to do them for horizontal. But for flat, we're going to do some weaves and see if we can't really get some nice stuff. Awesome. So that is it for today, folks. What I'm going to do is I'm going to open up your little quiz for you. It's one question today, and give you the answer to that one. If we have a bit of time left in the class, we can work on some stuff that we've missed, and that'll be that. So we are starting to run thin on some of the FAB stuff, guys. The outcomes aren't that much in the FAB 20 level for stick, because we go through a lot of it in 1050 at the 10 level. I'm going to expand on a couple lessons, and I'm kind of taking a few of the homework assignments, getting a little creative with them, just so we can get some marks for you guys, make sure everybody gets marks they deserve and has enough marks to pass the class. So with that, thank you much. If you haven't dropped your name in the chat, please do so. What I am going to do is take a shot of all the participants right now. That way, I have attendance for everyone here. So we'll close this down. I'm going to shut down the video. I'm going to stop recording. I'll shut the mic down, but I will be here for the next 10 minutes if you guys need any help. Okay, thank you much for coming to today's class. I hope everyone's warm, healthy, happy, and you guys have a great day. And yeah, just have a good afternoon. It'll be awesome. One more class and we're free. See you guys. Have a great day. Bye.